Hi everyone, I just want to show you a quick video about stationary points. So stationary points are where our curve or a function has no gradient at all. So this is usually where a graph turns or inflects. So I'll show you a turning point first of all. Let's say we have an ordinary cubic like this. And ultimately what I'm talking about is this. We've got a positive gradient that we can see, and that's here. We've got another positive gradient, which is here. And in between that, we have a negative gradient. It's only slightly negative, but it is negative, and that's there. So basically, when a function turns on itself and goes from positive to negative or negative to positive, it will for a very brief moment have no gradient. So I'm talking about here and here, thereabouts. So there is a gradient of 0 and a gradient of 0 as well. So this is called a stationary point. Stationary points, and that really means that our m or our gradient is 0, the slope is 0, dy dx is 0, delta y over delta x is 0, or rise over run is 0. See what I'm getting at here? Y2 minus y1 over x2 minus x1 is also 0. So all of these are just different ways of saying the same thing, that there is no gradient at those points. Now, obviously, we're talking about at a very particular point here, because we've been talking about gradient at a point for quite some time. Let me show you an example. I've got an example here of a cubic. So we can see when the function is graphed that it has two turning points, which means that it has two stationary points. And those stationary points we can see are at x equals -2 and x equals 0. This happens to be the function x cubed plus 3x squared take 4. If we didn't graph it, or we weren't shown a graph, or we weren't able to graph it, we would be able to find those stationary points mathematically. I'm going to show you how to do that right now. So I'm going to use this same function, x cubed plus 3x squared take 4. Let's have a look. F of x equals x cubed plus 3x squared take 4. So step 1, when we're finding a stationary point, is to find the derivative of our function. So this one's nice and easy. F dash of x is equal to 3x squared plus 6x. Okay, that's our derivative. Step 2 is to solve our derivative for x when the whole thing equals 0. Okay, so when the derivative is 0, the gradient is 0, the slope is 0, all of those, 0 equals 3x squared plus 6x. So in other words, our derivative is 0. What is x? Let's work it out. That is equal to 3x outside of x plus 2. And that means that x equals 0 and x equals -2, which is what we expected. Now, we haven't quite answered the question yet because we're looking for points, which means we need actually a set of coordinates, or in this case, two sets of coordinates, because there are two turning points. So step 3, find the coordinate. And we do that by plugging our found x values back into the original function. So we know that f of x equals x cubed plus 3x squared take 4. So when x is equal to 0, that means that we've got 0 cubed plus 3, 0 squared take 4, and that equals -4. When x is equal to -2, that means that we've got -2 cubed plus 3, -2 squared take 4. And that is equal to -8 plus 12 take 4, which equals 0. Therefore, the turning points, which are the stationary points, are at 0, -4, and -2, 0, which is what we expected. There they are right there. So that's how we would find it mathematically. So again, step 1, derive the function. Step 2, solve for x of the derivative when the derivative equals 0. Step 3, find the corresponding coordinate for those found x values. Let me know if you have any questions. We'll go over a lot more examples when we're all back together again. And good luck.